So in this video, we're going to be talking about transformations of functions. To do that, we are going to use Desmos.com. So I already have on Desmos the function y equals x squared. So you're going to commonly hear this referred to as a parent function. So a parent function is any function that has not been transformed or modified any way. So if I take a look at this function, and then I go ahead and I change it somehow, and I'll make it x squared, and then I'll make it minus 3, okay? What's happening here is we have a transformation called translation. Translation means something is going to slide. So in this case, because I hit minus 3, it translated down 3 units. So we can see from the parent function, the difference is it went down 3 units. So if I take a look at another function, or moving with this function, so again, we'll have x squared, but instead of just having x squared, what I'm going to do is I'm going to put parentheses here, and we're going to move this, and we're going to make this x plus 2, and I'm going to close the parentheses there, and now we have this green quadratic, which is now x plus 2. Again, that's a translation that was applied, okay? But we notice that we shifted to the left. If I changed this x plus 2 and I made it x minus 2, we would see that it would translate 2 units to the right. And that's all because working with the standard function, or the standard equation of a quadratic function, which is a times x minus h squared plus k, where h and k are the center, or the vertex rather, of that. So we can see here translations happen. It's just a sliding of left to right. So let's say I take this function here and I want to reflect it. Well, how I would reflect it is I would simply just go ahead and put negative right there and just flip that over. So now we can see, to do a reflection, I need to make this coefficient here, which is a, again, when we're dealing with the standard form, I need to make that a negative. So that's going to reflect that over the x-axis. So now what happens is, if I change the value in front of the x squared, that coefficient, let's say, for example, I make it 4. What it's going to do, and you can see the blue graph here, is it's going to go ahead and it's going to compress that and make that a little bit smaller. So if the a is greater than 1, the absolute value of a is greater than 1, that is, it's going to be a compression. However, if I take that same function and I make that, now instead of 4x squared, let's go ahead and make it a fraction. Let's make it 1/4, and then we'll go ahead and make it x squared. You can see here that the purple graph is a stretch, so it stretches it out. So that talks about dilations, right? So we can see here the blue one, it dilates, it makes it narrower, and the purple one, that 1/4, dilates and makes it wider. Now, if I wanted to play to this, I could also make this negative. Well, now it's a reflection with a dilation. And I can even go ahead and say I want to subtract 2. So now it's a reflection right here because it's negative, a dilation with the 1/4, and now we can see that it's been slid down with a translation of 2 units. So this is a very basic overview of transformations of functions. Just looking at quadratics. Remember, we're going to be transforming numerous functions. We may look at absolute value functions, exponential functions, even linear functions can be translated. So I'm going to go ahead and stop sharing the screen now, and I hope that you were able to pick up some tips on how to effectively graph transformations and what the transformations are.